In topic 4.3, we're asked to simplify radical expressions by factoring. So we want to look at a strategy for doing that. So 16 is not a perfect cube. X to the 11th is not a perfect cube. And you might say, is it a real number? Well, as long as the index number is odd, then it's okay to have a negative sign under the radical sign. So in class, we said the strategy to do this was to set up two radical signs. And what we're going to do under one radical sign is put any cube factors that we might get from that part of the radicand that is the number. Now if we divide 16 by 2, we get 8. And 8 is a perfect cube. And we're going to use the negative sign. We'll use negative 8 for this. And then 8 times what is 16? 2. So the protocol we're following is under one radical sign we put perfect cubes, and then any other factor that's left over we put under the other radical sign. Now for our value of x, we're looking for any power of x that is a multiple of 3. So the closest one to that is x to the 9th, and then x to the 9th times what is x to the 11th? Well, x to the 2nd. So now under one radical sign we have perfect cubes, and then whatever is left over is under the other radical sign. So now we take the cube root of this and simplify. This is a negative 2. And keep in mind we're just going to divide the 9 by the index number. And that gives us x to the 3rd. And then this part doesn't change. The third root of 2x squared. And that is the answer. Another type of example we did was to take the square root of this, and we're asked to simplify it, and again by factoring. So if we notice inside under the radical sign, the radicand, we can take out a common factor of 10. So let's do that over here. And then we end up with x squared minus 6x plus 9. And then if recall, this is the perfect square trinomial that will factor into, and I'm going to put this over here, the square root of, in parentheses, x minus 3, the quantity squared, and then just bring this over here to this side, square root of 10. So now when we take the square root of this, there's an index number of 2, and there's an index or an exponent 2. 2 over 2 is 1. It just then becomes the radicand. But that could have been a negative value, so to ensure that we protect that, we write the absolute sign here, and the square root of 10. Now, if we were not asked to ensure all real numbers and just have this as the positive value, instead of absolute signs, we would need parentheses here because it's a parenthesis. What is in the parenthesis, that's times the square root of 10. But absolute value signs also act as a grouping symbol. So another example. As we look at this next one, it's the fifth root of this, and we're asked to simplify it through factoring. Now we see the number 224, and we're wondering, is there a perfect fifth factor in there? Well, what I did over here is take the 224, and I started to find the prime factorization of it by dividing it by 2, getting 112, dividing that by 2, getting 56, dividing that by 2, 28, dividing this by 2, 14, and then ending up with a 7. Now, how many 2's do I have? Well, 1, 2, 3, 4, 5. So that is 2 to the fifth power, which is a perfect fifth. So let's keep that in mind. Getting back to our other method, we want to simplify this, so we're going to write two radical signs. Under one radical sign, we're going to put all of the fifths, perfect fifths that there are, and then whatever is left over, we'll put under the other radical sign. So we know in this, it's going to be 2 to the fifth power, which is 32, and then we have a 7 that's left over that we put in the other radical sign. Now we look at x. We have x to the 17th. What is a perfect fifth power of x? Well, it would be multiples of 5, so that would be 15. And what's left over? This times x to the second. Now, y to the 25th is a perfect fifth. So now under one radical sign we have perfect fifths, and whatever's left over we have under the other radical sign. Now we take the fifth root of this. Well, the fifth root of this is 2. The fifth root of this, we just divide the 15 by 5, and we get x to the third. Y, we divide the 25 by 5, y to the fifth, and then this is what's left over. Now the tedious part is just to put all of that into MathLab, but this was one of the examples I got right from MathLab, and hopefully this will be helpful for you in your work.